The objective of this test valve job is to test valves with water and air to identify leaks. The equipment used includes a test table with palm buttons, a crane, a lift table for a pallet of check valves, groove locks to connect hardware to bring the water for the test, a work table for tools, bolts, and groove locks. The tools used include an impact wrench to position and remove bolts, an air gun, a flashlight. The materials used include a check valve. The observed part weighs approximately 25 pounds. Larger and heavier valves are also tested. The personal protective equipment included safety glasses. Waterproof safety shoes or rubber boots are available. Latex gloves. The work environment is an inside work environment with heat and no air conditioning. The worker observed was 6 feet 2 inches tall. The work methods for the observed test valve job include lifting and carrying 2 check valves to test stations, rearranging check valves on the pallet, getting the impact wrench and loosening the bolts on the valves on the pallet, connecting the check valves using the groove locks to the hardware for the water test on the lower portion of the check valve. Tightening the groove locks using the impact wrench. Connecting the upper portion of the check valve to the hardware associated with the crane. Hand starting the bolts. Securing the bolts using the impact wrench. Connecting the hose to the check valve. Initiating the water test. Using the impact wrench to remove bolts from the check valve when the water test is complete. Using the crane to raise the check valves. Getting the air gun and using it to dry the inside of the check valves. Getting the flashlight and looking inside the check valves for imperfections. Moving the check valves to the work table. Emptying the water from the valve. Lifting, carrying, and positioning the check valve on the pallet with parts that passed the tests. There were several ergonomic risk factors observed for the test valve position. Repeated and sustained exertions were rated as a medium pace. Hands were in steady motion and exertion to position and set up check valves for water and hang tests. Pauses in hand activity occurred while waiting for tests to be completed. The work is self-paced. Sustained exertions were observed and included continuous standing, continuous torso flexion or forward bending when using the impact wrench, Forceful exertions were required to lift, carry, and position check valves on the work table and pallet. Empty water from the check valve by holding the valve upside down. Engage the impact wrench. And to connect and disconnect the water test hose. Awkward postures were observed and include torso twisting and neck extension or backwards bending to look inside the elevated check valve using the flashlight. Neck flexion to position and connect the check valve to the fixtures for tests. Elevated arms to connect the water hose. Neck and torso flexion and extended arms while positioning components. Torso flexion, torso lateral bending or sideways bending, wrist extension, and forearm supination and pronation while using the impact wrench. Elevated arms while using the lift assist. The mechanical or localized contact stress observed was contact stress between the hand and forearm and edges of the parts. It's important to note that gloves are worn. Workers were exposed to vibration while using the impact wrench. The recommendations for the test valve job include: investigate using adjustable height workbenches to decrease posture stress. Consider using the crane to lift and carry the check valves to and from the pallets. Investigate suspending the power tools overhead to decrease forceful exertions and decrease trip hazards. Investigate vibration reduction handles or other vibration isolation devices on the power tools to decrease vibration exposure. Consider using anti-vibration gloves that are also cut resistant to decrease vibration exposure. Investigate different tools to replace the impact wrench to decrease vibration exposure. Investigate using a crane to support the impact wrench that will transfer the vibration away from the worker and reduce the weight/force required to support the tool. Use a fixture that can hold the part and is attached to a large frame that allows the part to be rotated for working on different areas of the part. Use a telescopic arm that can hold the vibrating tool. This will decrease the amount of vibration transmitted to the worker's hands, since most of the vibration and torque of rotation will be transmitted to the telescopic arm.